These are not the only single qubit gates that we can have, of course, but actually there's a theorem that we'll be able to express any single qubit gate as a product of these. Hopefully that's intuitive from this geometric intuition, right? Starting in a state, for example, the zero states, our goal is to get anywhere else on the surface of the Bloch sphere. Let's say the surface, we're working with pure states. So hopefully you agree geometrically that if I first rotate about the z-axis, and then about the x-axis, and then about the y-axis, I'm able to get to any point that I want to on the Bloch sphere. Does this make sense geometrically? What we're saying is that any single qubit gate can be expressed as a product. So we have this theorem. Any single qubit gate U can be expressed in the following way. U being Rx of some angle. Let me match the textbook. For now, let me just use some angle theta x, Ry of theta y, and then Rz of theta z. And you might think that there's only 3 parameters here, and when in principle a single qubit unitary is a 2x2 matrix, so there's 4 degrees of freedom, and the one that we're missing is the global phase. So we can also add that in if we'd like as e to the I alpha. So just from this geometric reasoning, any single qubit unitary will correspond to some rotation about this Bloch sphere. We'll be able to achieve that by finding some angles, theta z, theta y, and theta x, that we can apply these rotation operators to get to that state. Okay? So you could, of course, do it in this way with all 3 rotation gates, but there's actually a slightly simpler way. If you only have 2 of them at your disposal, that's going to be sufficient. So we have in the textbook theorem 4.1, which is called the zy decomposition. It's going to be the exact same reasoning that we have here, except for the statement is only in terms of z and y. So I can write any single unitary u that I want as some global phase, which maybe we do or maybe we don't care about, times Rz, in this case we'll use the angle beta, Ry of angle gamma, and then another Rz of angle delta to match the textbook, where again these in the same case are just some real numbers for some real alpha, beta, gamma, delta.